guys, and welcome back to yet another video. In today's lesson, we're going to learn how to solve multiplicative comparison word problems with fractions. Try saying that 3 times fast. And this is just a fancy way of saying we're going to be solving word problems that require us to compare fractions using multiplication. These are our buzzwords. We know that whenever we're solving word problems, it's very important that we utilize our buzzwords chart. And these are the strategies that we've learned. If you are still stuck on any of the strategies listed, go ahead and check out my previous videos. Let's go ahead and solve our first problem. It says Tamika ran 2 5/8 miles. Her sister ran twice as far. How far did Tamika's sister run? Now let's read it again. This time, I want you to see if there are any key details that I can pull out from this first sentence. Do you see any key details that I need to underline? That's right, the fact that Tamika ran 2 5/8 miles. What about from the second sentence? Do you see any key details? That's right, her sister ran twice as far. And I know I'm solving for how far Tamika's sister ran. Now let's look at this problem again, this time looking for any buzzwords that I can pull out. Do you see a buzzword? That's right, twice. And what does twice tell me to do? That's right, I'm multiplying. If I look back at my buzzwords chart, twice is under the multiplication category. I'm multiplying. Twice means 2 times. So I know how far Tamika ran. I just need to figure out how far her sister ran. Let's put an S for sister. If her sister ran twice as far as Tamika, what is going to be my multiplication equation in order to solve for her sister's total distance? That's right, 2 times 2 5/8. This will give me the total distance that Tamika's sister ran. And I want to use repeated addition for this problem, because I have 2 copies of 2 5/8. There's 1 copy. And there's the other copy. Now, don't forget to combine like terms. We're combining our whole numbers and our fractions. Go ahead and combine your like terms and let me know what you got. Did you get 4 10/8? Me too. What'd you do next? That's right, I have to decompose 10/8 because I can pull out a whole within 10/8. What did you get on your left-hand side? Awesome thinking. And what about your right-hand side? Good job. Don't forget to rename 8/8 as a whole number, so we're renaming it as 1 whole. 4 10/8 is the same thing as saying 4 plus 1 2/8. So what's my product? That's right, 5 2/8. 5 2/8 is the total distance that Tamika's sister ran. So Tamika's sister ran 5 2/8. Let's try another problem. This problem says, Natasha's sculpture was 5 and 3/16 inches tall. Maya's was 4 times as tall. And how much shorter was Natasha's sculpture than Maya's? Now, let's look at each sentence identifying key details. What am I going to underline in this first sentence? That's right. The fact that Natasha's sculpture was 5 and 3/16 inches tall. What about the second sentence? What am I going to underline? That's right, the fact that Maya's was 4 times as tall. And I know I'm solving for how much shorter was Natasha's sculpture than Maya's. I don't know how tall Maya's sculpture was, though. So this is actually going to be a two-step problem, because I have to solve for how tall Maya's sculpture was, and then I also have to figure out how much shorter Natasha's sculpture was compared to Maya's sculpture. But before I do that, you guys, are there any buzzwords in this problem that can help me solve? Look carefully. That's right, times. What does times tell me I need to do? That's right, multiply. If I look back at my buzzwords, times is right in the multiplication category. Times means multiply. So I need to solve for Maya's sculpture. What am I going to be multiplying in order to solve for Maya's sculpture? The height of Maya's sculpture. That's right, 4 times 5 and 3/16. This will give me the total height of Maya's sculpture. This time, let's use the distributive property, mainly because I already decomposed my mixed number into a whole number and a fraction by basically just writing them in different colors. So that means I'm going to be multiplying 4 times 5 and then 4 times 3/16. I'm going to be distributing that 4 wholes to both my 5 and 3/16. What two numbers am I going to put in my first set of parentheses or my first partial product? That's right, 4 times 5. What about my second set? That's right, 4 times 3/16. And now you guys, let's solve. Go ahead and solve for your first set of parentheses. If you're done, start working on your second set of parentheses. Four times 5 is 20. Now what about that second set? 4 times 3/16. What'd you get? That's right, 12/16. Because 4 times 3 equals 12, and my denominator stays the same, 12/16. Now let's go ahead and add them together. But before we do, let's focus on 12/16. Do I need to decompose 12/16? Why not? That's right. I don't need to decompose 12/16 because 12/16 is less than a whole. So I'm just going to combine 20 and 12/16. So I get 20 and 12/16. I now know the total height of Natasha's sculpture, but the problem wants me to figure out how much shorter Natasha's sculpture was than Maya's. So what do I need to do? Remember, Natasha's sculpture was 5 and 3/16 inches tall. So let's put n equals 5 and 3/16. This is Natasha's sculpture height. This is Maya's. What do I need to do to figure out how much shorter Natasha's sculpture was than Maya's? If you're struggling, I know I'm looking for the difference. I'm finding the difference between these two numbers. What operation tells me to find the difference? That's right, subtraction. So let's go ahead and subtract Natasha's height from Maya's height. So 20 and 12/16 minus 5 and 3/16. Go ahead and subtract like terms. $20 minus 5 is 15. And now 12/16 minus 3/16. What'd you get? That's right, 9/16. 15 and 9/16 represents how much shorter Natasha's sculpture was than Maya's. So Natasha's sculpture was 15 and 9/16, don't forget your unit of measurement, inches shorter than Maya's. Thanks guys so much for watching this video. Catch me in the next video. See you later.